Hey guys, it's NanoTube, and today I'm back with quite a different video. I've been working a lot with the Royal Scientific Society to make a cool food experiment for you guys to enjoy. We wanted to choose a food experiment that had to do with the Jordanian cultural heritage. If you guys are revisiting my channel, today's video will be a little more advanced than my previous videos. So maybe you learned something new today. A lot of work was put into making this video happen. So if you guys do like it, please consider liking the video down below and put in the comments any new experiments you want me to try out on the channel. And also consider subscribing to the channel. I would really appreciate it, and it would help the channel grow. And before the video starts, I'd like to thank the Royal Scientific Society. They've helped me so much throughout this journey, as I've learned so much because of them. Now let's get into the video. Hi there, my name is Rayyan Kiswani. I'm 15 years old, and these are my two colleagues, Sara Tabbalat and Aya Mansour. And we reside in the beautiful country of Jordan. Jordan is renowned for its physical beauty. The historic charm of the ancient city of Petra, the stunning castles and plains of Wadi Rum, and the unique wonder of the Dead Sea are only a few of Jordan's many exquisite features. The warmth and generosity of the Jordanian people, however, are no less exceptional. And an aspect that Jordan is widely acknowledged for is its rich cuisine. At tables across the country, Jordanian cuisine is a delicious immersion in the country's diverse heritage. A vibrant mix of Bedouin flavors and local takes on the Levant's most iconic dishes. Whether you're sipping sweet tea in Petra or looking for Amman's tastiest falafel, cuisine is an essential part of the Jordanian heritage. A component that you would find in most, if not all, Jordanian dishes is this: olive oil. Olive oil is the base ingredient of all the food that we eat here in Jordan. You'll find it in dishes for all meals, from breakfast to lunch to dinner. And it's also a component of our national dish, mensaf. And I can assure you, in any Jordanian kitchen that you visit, you will find a bottle of olive oil. The production of olive oil is a part of the Jordanian terroir. In the north of the country, every family owns its own private olive grove. Ajloun, Irbid, Qais, and even Amman, everyone has good reason to be proud of his production. Olive oil is the principal cooking oil of countries in the Middle East, where it has been produced for thousands of years. The Romans used it as fuel for lamps and cooking. The cooks of the Ottoman kitchens as well devised recipes where olive oil was not only the cooking fuel, but also the principal flavoring ingredient. We chose olive oil for our experiment because we wanted to recognize an ingredient that could display our Jordanian culture and cuisine to the greatest extent. Nothing can compare to the colossal feeling and importance that olive oil has on all Jordanians. The olive sector is considered one of the most important agricultural sectors in Jordan. Jordan is the 8th largest producer of olive oil in the world, with over 20 million olive trees. Olive oil has also proven to have multiple health benefits. The phenolic compounds in olive oil have been proved to protect against many diseases. It can lower blood pressure, it can prevent strokes, cancer, Alzheimer's, diabetes, and liver disease. Despite the strong scientific background on health benefits related to phenolic compounds in olive oil, this information is not used when marketing Jordanian olive oil. This is due to the lack of information regarding the type and amount of phenolic compounds present in Jordanian olive oil. One of the main challenges facing the Jordanian olive oil industry is the lack of modern marketing. The possibility to use such a health claim in the Jordanian olive oil industry is very important from a marketing standpoint. However, at the moment, there's no research done about phenolic compounds in olive oil produced in Jordan. Moreover, the amount of phenolic compounds present in olive oil depends on many different factors. Therefore, our experiment will provide important information for farmers and producers to determine the optimum harvesting periods for olives to maximize the phenolic content. The knowledge transfer during the implementation of the project will be ensured through a wide community of relevant companies and the research institution involved. In our experiment, we'll be using 2 samples of olive oil and having 2 readings on each. We will also work with 5 different concentrations of tyrosol to create a calibration curve which will help us identify the concentration of phenols in each olive oil sample. I will have all the materials needed for the experiment right up here on the screen. So our first step for the experiment is to prepare our tyrosol stock standard. So firstly, you'll need to weigh 25 milligrams of tyrosol. Then we put in our 25 milligrams of weighed tyrosol into a volumetric flask, which then we will add 25 milliliters of methanol water. Then we will use a vortex to mix both the tyrosol and the methanol water. You will put it in the vortex for roughly 2 minutes. To be honest, my hand was quite numb after that one. Now we can find the concentration of the tyrosol stock. You do this by using a fraction, where you put the weighed in tyrosol over the volume of methanol water used. Then multiply that by 1000 to get the total concentration. Our next step is to prepare the tyrosol working standards. The concentrations that we're aiming for the working standards are 100 through 500. To find the desired volume of tyrosol standard that we'll need in each of the working standards, you need to do an equation where you add the desired concentration for that specific tyrosol working standard, then put it over the concentration of the tyrosol stock standard. This way you'll get the exact volume needed to add into each of the working standards. After calculating the volumes, prepare vials and label each one with each concentration. And based on the volume that you got for that specific concentration, you put it in a designated vial. Now in each vial, you'll add a specific volume of methanol water to dilute the stock standard. The specific measurements for each concentration will be up on the screen right now. To achieve all these desired volumes, we used a micropipette to get the most exact measurements. Now, after everything is added into each vial, you will take the vials and refrigerate them while we're working on the olive oil samples. Our next step is to prepare the olive oil samples for the UV measurement. Now we take out our 2 olive oil samples and we make 2 trials for each one. Now, weigh as close to 2.5 grams of olive oil into a centrifuge tube using a dropper. These were the masses that we gathered for each trial of each sample. Next, in each centrifuge tube, add 5 milliliters of N-hexane. Then, add 3 milliliters of methanol water in each centrifuge tube. Remember, all these measurements will be done using a micropipette. Next, you vortex each centrifuge tube for 2 minutes. Again, your hand might feel quite numb.
A few moments later.
After putting each centrifuge tube in the vortex for 2 minutes, we will put it in a centrifuge for 10 minutes at a rotation of 3,500 rotations per minute. After the 10 minutes, the polar properties of oil will be displayed, as you will see 2 different layers fully separated. Then you will take 4 new labeled flasks, labeled for each sample and trial of olive oil, and you will take 3 milliliters of the bottom layer, the polarized layer, and put it into each flask. Then you will add another 3 milliliters of methanol water into the centrifuge tube. Then you will add the centrifuge tubes again into the centrifuge for 10 minutes at a rotation of 3,500 rotations per minute. After the 10 minutes, you will repeat the same steps by taking the polarized layer at the bottom, 3 milliliters of it, and adding it to the 3 milliliters collected before. Now, each flask should have 6 milliliters of the polar liquid. Make sure when extracting the 3 milliliters of the polar layer, not to take in any of the olive oil. Now, you will take 4 new test tubes for each trial and each sample. You will label them and put 0.2 milliliters of their own polarized layer into the designated test tube. Then, in each test tube, add 2.3 milliliters of distilled water. To each test tube, we will then add 0.25 milliliters of fallen Cicalto reagent. Then wait 3 minutes. After the 3 minutes are over, add 0.5 ml of sodium carbonate solution. Then you will use your hand to mix each test tube well. Add another 1.75 milliliters of distilled water. Then cover each test tube with paraffin. Then put each test tube in a cupboard for 90 minutes where it's exposed to 0 sunlight. This will make it so no external factors can affect our results. After putting our olive oil samples in the cupboard, we will go to the fridge and take out our tyrosol working standards. Then you will take 0.2 milliliters of each tyrosol working standard and put them into 5 different test tubes that are labeled. We will repeat the steps that we did for the olive oil samples by firstly adding 2.3 milliliters of distilled water. You will add this into each test tube. Next, you add the 0.25 milliliters of fallen Cicalto reagent. Then we wait another 3 minutes. Now, after the 3 minutes are over, you'll add 0.5 ml of sodium carbonate solution into each test tube. Then mix well with your hands again and add 1.75 ml of distilled water. Cover each test tube with paraffin, then add it in the cupboard with the olive oil samples for 90 minutes.
One eternity later.
Now, after those long 90 minutes, you'll realize a slight color change between the test tubes. Redox reactions happen between phenolic compounds and the fallen reagent in the alkaline medium. This formed a blue complex. Now, when we go to the UV-Vis spectroscopy machine, this blue complex will be detected. This is because it will be absorbing the radiation, and the machine will give us the exact number of absorption for each test tube and each sample. We will be testing the absorbance at 725 nanometers. Now the calibration curve will be made based on the absorbance and the concentration, where the absorption is on the y-axis and the concentration is on the x-axis. Through this calibration curve, Beers-Lambert law is proven, where when there's a higher concentration, the absorbance is higher. The theory of Beers-Lambert law is based on the fact that the amount of radiation absorbed at an appropriate wavelength is directly proportional to the concentration of the absorbing species in the sample. This is proven through our calibration curve. And through the calibration curve and the absorbance for each sample of olive oil, we're able to find the concentration of the phenols. And now we can use an equation to find the amount of phenolic compounds in each sample. Now the equation will be right up on the screen here. It shows that the number of phenolic compounds is equal to the concentration multiplied by the volume of the polar extract over the weight of the sample. Here's this equation implemented on the first trial of the first sample of olive oil. Now this is the calibration curve that we got. And these are the values of phenolic compounds that we got for each olive oil sample. Now that we're done with the experiment, I'm really happy with the results that we took home. We got to see that sample 1 had a lot more phenols than sample 2 did. By sharing this information, we can see what sample 1 did to get this high amount of phenols. So other oil companies and oil producers can do the same thing and increase health benefits around Jordan. We're so happy through this experiment we got to use science to help out our country and different citizens to increase health benefits of olive oil and to make olive oil more healthy for all of us. We're glad to have used olive oil in a healthy way to help out our community. Finally, I'd like to thank my colleagues, Sara Tabbarat and Aya Mansour. I'm sure I was quite a burden on both of you guys throughout this journey, but I'd like to thank you guys so much for everything that I've learned. I would also like to thank Dr. Diya Safadi and Dr. Kyle Corrado for lending me their labs and equipment to help to implement this experiment. And a big thanks to the RSS as a whole. You guys have taught me so much through this journey and I couldn't have done it without you. I hope you enjoyed the experiment and saw the benefits that it had on our community as a whole. Thank you. Bye.